Yeah, I'll check when I get back home, because yikes. What time we got? We are 7 o'clock straight up. Am I coming through online? All righty. Hi, everyone. Welcome to this meeting of the Warren Astronomical Society. I'm your president, Bob Tremblay. Let's see. Tonight, our short talk will be The Importance of Astrology to Astronomy by Ken Burton. And our main talk will be Telescopes by Adrian Bradley. So stick around for our talks. Do we have any first-timers tonight? We have a couple first-timers. Okay, well, you heard about us on Meetup, right? Well, anyway, so we have an observatory at Walcott Mill Metro Park. We do a observatory run every fourth Saturday of the month, free, and that is coming up. And we also meet at Macomb Community College South the third Thursday, which is next week. So you can renew your membership with this fellow right here during the break. Memberships get you a badge and a lanyard. Now, as a tradition, we like to go through the ranks and do a roll call to say who's here. So, hi, Bob Tremblay.
Dale Kimmy, editor.
David Moransky, treasurer.
And Burton.
I'm nobody.
You are somebody here.
Everybody's somebody here.
Bob Burton.
Brian Wazeski.
Laura.
Adrian.
Dale Barton, first vice president.
My name is Kevin. I've never been here before. This is my first time.
Welcome.
Welcome. Hi.
Jim Wallace.
Mark Kitzer.
Jeff McLeod, outreach.
Sonny Spiles.
Tina Wong, card carrying member.
Oh my God, I read my card. Yikes.
Ken Ward.
Jill Manning, member. Kathy Russell. Ann Byrne. Amy Clark.
Patrick White.
Hi there. All right, so W.A.S wearables like shirts and sweatshirts are available from Mark Kedzier, who is in the audience here. You can see what's available in our newsletter. W.A.S stickers are available for your laptop or phone or what have you. Those are down here. We are a member of the Great Lakes Association of Astronomy Clubs. They meet every second Tuesday. They host the Astronomy at the Beach event, which was coming up in September, and we're going to have a table excuse me, under the club tent, like we usually do there. And usually I man that, and we invite club members to come and sit and just chat with the public and stuff. But this year, my boss is going to be the guest of honor, and he is going to be crewing the Vatican Observatories table, and he wants me to work with him at the Vatican Observatory table. So I might be tag teaming it, and I might need a couple more people to sit under the club table this year. So at a recent G.L.A.A.C meeting, they mentioned that they are looking for lecturers from other clubs. So if you're interested in giving a lecture here, you can also give the lecture at other clubs, and there's several of them in the southeastern Michigan area. Officer reports. There's an article in our current newsletter about the Paul Strong Scholarship by Jonathan Cade and Dale Parton. I read most of it before I got real busy today, but there are things in there I didn't know, which is one of the reasons I wanted to have that written, and I also want to have that put up on our website. So Paul Strong was instrumental in getting us into Macomb. He was a very active member, and he was before my time. I never knew the guy. So I know some members here actually knew him. We have a sad announcement here. Gary Gathan, a longtime member, passed recently. He used to host our discussion group at his house quite frequently. His service will be Friday, July 25th at 10 a.m. at the Shrine of the Little Flower Catholic Church in Royal Oak. I sent out an email to the membership about that. That's pretty darn sad. Okay, so Dale, what is our first vice president got for us? I know what he's gonna say. Actually, you got long presentations, right, for the year?
Yes. I need presentations, you guys. Strangely, I'm finding it somewhat easier to get long, full-length presentations than short 10, 15-minute presentations. That's because increasingly I'm reaching out to people far away, in addition to people from our own organization. And you can't invite an outside speaker to give a 10 or 15-minute presentation, right? So if you have something that would be short, let me know. Otherwise, I don't have somebody even for next month for a short presentation.
I have been requested by Laura to do a short presentation showing recent photos, Milky Way photography.
Okay.
I'm sure I can put something together about how and where to do it.
Okay, so Adrian Bradley is volunteering to give a short presentation. I need more, okay? Thank you.
How to get this?
I've got an idea, Dale. I'll get with you. I'll get with the break about showing a video. Riyadh, what's going on at the observatory?
Yeah, thank you, Bob, and hello, everyone. Last open house we had was on June 28th, Saturday. We opened the observatory about 7:22, and the sky was clear for the entire night. We used the 8-inch refractor to observe the moon, Mars, a lot of deep sky objects, and a number of double stars as well. We had about 6 telescopes set up outside the observatory. People were observing outside as well, and imaging as well. And we had a new member that checked out one of our loaner scopes, the 6-inch Criterion Schmidt-Cassegrain. And I'd like to
Is he keeping it?
Pardon?
Is he keeping it?
Well, she may keep it for a little while, but
Cool.
I'd like to remind everyone we still have a couple more available for checking out, a couple of 8-inch Dobsonians. So if you're a member, come on and see me at the open house and we can set you up. We just need a deposit, just a check, and we'll return it to you when you bring the scope back. So we were out observing all the way until we closed the observatory about 1:40 a.m. When everybody left. And it was we had about 50 people or so, 45, 50 people showing up, and a number of members showed up as well as visitors. And it was a really interesting evening. So the next open house is scheduled for July 26th, also starting at 8 p.m. Also, I want to remind everyone that the Perseid meteor shower is coming up August. So that's August 12th, but our open house for the Perseid meteor shower is going to be on Saturday, August 9th. So it's on a weekend. This way, everyone hopefully can show up, and we highly encourage people to show up. It's a great evening. Bring lawn chairs or blankets or whatever you want to put on the ground, and
Bug spray.
usually, it's like a picnic at night. It's a lot of fun. So hopefully we'll see everyone on July 26th, and then also August 9th, and of course, let's not forget our picnic is coming up after that as well. So the picnic would be on August 23rd. Yeah, August 23rd. So that's all I have. Thank you.
All right, thank you, Riyadh. David, what is going on? This is our secretary, our treasurer, David Baranski. Secretary, is Charlie here?
All right, so in our checking account, we've got $23,106. In our PayPal, we've got $683. Our cash box, we got about 170 and some change. We do have a balance on a credit card of about $177. And if anybody needs a sticker for telescope or anything, they're $1 a piece. 7 of them, you can get them for $5. That's it.
All right. All right, our secretary is not here. Jeff, what's going on with outreach?
Well,
I just noticed these.
They're telescopes.
Is this anything I want? No, I've got enough, okay.
We'll find you, you're gonna be a part of the presentation later.
Oh boy. I'm just gonna tilt the camera down for no particular reason. Okay. Can't beat them, join them. Okay, so the same night as the open house, myself, I'm too loud? Mark's saying I'm too loud. I'll step back. I project. I don't actually need a microphone. Myself, Mark, Tina, we were out at Dodge Park is the location. Sterling Heights Nature Center put on an event where they were doing some overnight camp out thing. They had a bunch of different activities. We were just doing the astronomy part. So myself and Mark both brought 8 inches of different types.
I just noticed what was on your shirt.
Oh. Okay, it's ET. We had a pretty good night. So we saw the same things that Riyadh did. We started with the moon, Mars. The crowd was kind of younger, so the deep sky objects were a little challenging. And we didn't go till 1 a.m. The sprinkler system kicked us out right before midnight. We very rapidly moved our telescopes and then just decided, you know what, I think we've had enough. So that was last weekend. Riyadh mentioned the picnic. I just want to stress, the club is providing burgers and hot dogs. Beverages?
Yeah.
Beverages. Mark, are you grilling?
Yeah.
Awesome. I'll probably pick up the burgers and stuff again. It is your job for side dishes. Please bring side dishes.
What's the date?
August 23rd is what I have in my calendar, and that's what Riyadh said, so take that to the bank. That is at the pavilion down the way from our observatory out at the Wilcott Mills Metro Park. Yep, and then typically we hang out, it starts to get dark. If it's a nice night, we open the observatory up and we have kind of impromptu open house. The other stuff on the list is astronomy at the beach. I know it still kind of seems far away, but it's like, in my mind, rapidly approaching.
We have to start advertising it.
So you can help out to almost any capacity. We need people at the tables. We need people running scopes. We need people running our big scope, please. Otherwise, it's just Mark and Riyadh again. So yeah, info at Warren. Talk to him. Talk to me. Talk to Mark. Talk to any of us. Talk to Tina. And we'll figure out how you can help us. Thank you. And nothing on the history. It's like an odd, between the last meeting and today, there's like no Apollo, Gemini history, but next meeting, there'll be quite a bit.
All right.
Jiminy,
What's that?
isn't it pronounced Jiminy?
Yes.
Yes, it is.
Pronounce it that way.
Okay, our Vachalia, is she here? No. Okay, our newsletter is up. Dale publishes our newsletter. We have an award-winning newsletter, or award-winning newsletter editor. Which is it? I'm not sure which, but he won an award, and the newsletter is awesome. So if you need to contact us, you can contact us at either info or at board@warrenastro.org. Let's see, David Levy on? David Levy is not on. All right. So astronomy.
Real quick,
Hmm?
Astronomical League
Yes.
announcement, real quick.
Come on up.
The short version's about 30 minutes, so settle in.
Another short presentation.
Short. All right, so I am the invisible Alcor for Warren, the Warren Club. The Astronomical League met at Bryce Canyon this year. They wanted to do some actual astronomy as a part of the conference. Well, as it turns out, there was a wildfire nearby, so the nice dark skies were marred a little bit, the transparency from the nearby wildfire smoke. It wasn't actually at Bryce Canyon, but it was close enough that you could see the tufts of flame over there, and you could see.
That's too close.
Yeah, the smoke. Yeah, people were wearing some masks if they're worried about the smoke inhalation. But the winds would blow at night, and at times they would blow the smoke in a different direction. you still had sky to observe and image from. So all in all, it was a great event. It was well attended. I drove out, a few others drove out. If you remember Dr. Brian Odom, who gave an astrophotography talk, he gave a talk there, as well as several other folks were there. There were awards and prizes given out, and a lot of talk about the Sea Star. And I'll get into the Sea Star when I go into my presentation. But it was a good event. The next event will be in Cincinnati next year, so a little bit closer. You all are welcome to come. I will be submitting the final roster sheet. I talked directly to Mitch, the person who organizes them, and he gave me a personal extension. So I can get it in by July 15th. I will be emailing it to him very shortly, and I will be hitting up our treasurer to send them some money. Preferably from PayPal, because it's probably the easiest way to do it. Checks are always welcome, but I've been known to be slow at delivering checks. So, Astronomical League, if there's interest, you can talk to me after. Those of you that are members and members of the Astronomical League, fear not, your reflector magazines will begin coming after the roster's coming in August. You should start seeing copies of the reflector. I have copies, I didn't bring them, but I will bring them in. If anyone wants a copy of some of the previous issues, I will be glad to share mine with you indefinitely. So that's it for the Astronomical League.
Thank you. All right, astronomy in the news. We have a third interstellar comet, and it is cruising through the solar system. Comet 3I Atlas was discovered on July 1st. Its closest approach to Earth is going to be about 1.8 astronomical units, so nice and far. It's going to pass fairly close to Mars, though, and we happen to have a fleet of spaceships there, some with telescopes, so they're going to be looking at it. Scott Manley did a great video on YouTube about it, and there's just countless articles online about it right now. The Vera Rubin telescope is now online. It is likely to discover a boatload of these interstellar objects passing through. Have you guys seen the images? No. Oh my goodness. Yeah, look, when you get home, look up Vera Rubin first images. They took a picture of the Trifid Nebula in that area, and it is 10K by 6K. It is ridiculously huge, and it's absolutely gorgeous, and it's on the back of my computer at home. There may have been an impact flash on Saturn. This was from spaceweather.com. An impact flash may have been observed on July 5th between 9 and 9:15 UT. If anybody observed the planet around this time, please check your images. If confirmed, it would be the first ever impact flash detected on Saturn, which is pretty cool. Asteroids, we've got 1,000,004, and near-Earth objects, we've got 38, almost 39,000. Exoplanets, my favorite, we're getting really close to 6,000 confirmed, 5926 and 7655, and the Vera Rubin telescope the Gaia. When the Gaia releases its data, it's expected to find a whole bunch more exoplanets. Vera Rubin is expected to find a whole bunch of asteroids. In the first hour of operation, the first test images, they discovered 2,000 new comets in the test image, 1 hour. Asteroids. It's crazy. And the whole name of it is DOD/NSF Vera C. Rubin Observatory. Well, the reason it's DOD is because DOD realized that this thing would be real good at finding spy satellites in secret orbits. And so all the data collected by this telescope goes into a secret room and secret servers, and satellite data that they don't want you to see gets scrubbed. A whole data is released like days later once the orbits don't do you any good anymore. But that's why the DOD is in there, because it's so good at finding things, it can find spy satellites. Let's see, a recent NASA exoplanet archive release includes Kepler 725c, a planet of 10 Earth masses located in a sun-like star optimistic habitable zone, 2,400 light years from Earth, and it's got a 207-day orbit, and it is the first exoplanet discovered using the transit timing variation technique. So I'm going to have to update my lecture about that because that's new. Special interest groups. The predicted nova of T Corona Borealis still has not occurred, and we're not due, or we're almost due. The sidebar on spaceweather.com actually shows it down in brightness from yesterday. So yeah, who knows what's going on with that.
There was that nova and lupus if you wanted to see.
Ooh, yeah, there was. I forgot to say that. There was a visible, a naked eye visible nova in Lupus, the constellation Lupus. We have a bunch of sunspots. Let's see. Okay, observing. We have any observing reports. The moon's out. Anybody see anything cool?
I saw the man in the moon.
You saw the man in the moon. So my granddaughter went up to Sleeping Bear. No, I'm sorry. Come on, Beaver Island. I know that they recently got a dark sky certification, but she didn't get to see it. What she got to see are deer flies for the first time. So she was not a fan. All right. So if there are no observing reports, let's get to our presentation, Ken, and let's get your keynote back up here and shared. We gotta get this launched. And I have no idea how to launch this on this Mac. I'm a Windows guy. Okay. Gotta get rid of that. And gotta get rid of that. And what I gotta do is I gotta find. Let me do the presentation. This is. Come on. Come on. I don't know what it just did. We'll get there, I promise you. Trying to find out where it is. I don't see it. I didn't delete anything. I know you didn't. I don't know how to delete things on this thing. I have no idea what I'm doing here. Give me a second here, please. Windows box. What's that? I don't know what it's doing. Oh, there we go. There we go. Okay. Got it? No, I don't got it, but I'm getting there. I thought we had it a moment ago. Let's do this. Come on. It was there and it just disappeared. Oh, there we go. Here it comes. Here it comes. I hope. Anything going up there? I'm trying to figure out why it's not letting me. Now this should be right in here. Okay, there we go. All right, so now. Okay, and this is, launch it and do the. And I can launch it. Presentation view, and then I got. I don't know why it's not doing that. It should be coming right up. Play. Is that it? Is it? And where's the other picture? You're in presenter view. Yeah, but that's supposed to go up there. Is what the picture? Oh, there we go. Okay, drag that over, and we gotta put that on top of the Zoom. Nope, wait a minute. That's not what I wanted to do. Okay, does that go? There we go. We're gaining on it. And we gotta share it. I know. Where'd it go? It's over on the other screen. No, I'm saying where's the Zoom? Okay. Share on the bottom. There? Yep. Share that. Share. Yeah. Okay. And what do we? Share that. Yep. Share. And now. All right, you gotta go back one anyway. Okay. All right, now we gotta get the screen large. Undo that. There it is, there's a mouse.
Yeah, I know, but I'm just trying,
Grab the top and drag it up.
will do. And we can do this too. Bingo.
All right, we there?
I guess so.
Can you see that, Dale?
Yeah.
All right,
You see that okay?
they're seeing it. All right.
Okay, all right. Here we go. Well, you give the introduction, yeah, sure.
Well, now that the G.L.A.A.C stuff is done, few comments about Ken Burton, although anybody that's been part of this club for any length of time at all is familiar with Ken. He's been an amateur astronomer for more than 65 years.
Try 70.
Must have started when he was about 2.
I was 6. It's okay.
And he has quite a bit of history with this organization. He's been our president and our vice president. And he's won some awards here, the Searles Award, and he also is granted a lifetime membership, which very few people have been granted that. And he's out of control with going to see ellipses of the sun and the moon. He must have made the airlines wealthy going to all those places. And one of his specialties is giving presentations on historical figures recently, who are important in astronomy. He gave one recently on Carl Sagan. And tonight, he's talking on the historical influence of astrology on astronomy.
Thank you, Dale. Anyway, the unaccustomed as I am to speaking before groups, that's a lie. Okay. All right, let's get this back where it's supposed to be. Give me a second. There we go. Okay. Let's see what I did here. I've got this other screen sitting up there, and I don't know why it's there, but we'll find it. Okay. Astrology and astronomy have a long intertwined history, but today, darn it, hold it. I'm sorry, gang, this is unnecessary to go through this. Okay, there we go. That's what I need, and I need this out of here. There we go, I'm good. Okay, astrology and astronomy have a long intertwined history, but today they are very different in nature. Here's a clear breakdown of astrology's effect on astronomy, both historically and in terms of modern influence. Yes? What's that? Okay. Did everybody hear the first part? Good. I'm glad to hear it. Okay. All right. Historical influence of astrology on astronomy. In ancient times, astrology and astronomy were indistinguishable. Civilizations like the Babylonians, Egyptians, Greeks, and Chinese studied the skies primarily for astrological purposes to understand divine messages, predict events, and guide human affairs. Early astronomers often were also astrologers, mapped stars and planetary movements to develop calendars, track seasons, and cast horoscopes. The need for precise planetary positions for astrological predictions led to the advancement of observational techniques and early astronomical instruments. First of all, the zodiac system, I guess I could do that. Did that come over? It did. Okay, let me go back. The zodiac system, developed by Babylonian astrologers, it became a framework still used in astronomy to divide the ecliptic. The Ptolemaic model, developed Claudius Ptolemy's Almagest astronomical and Tetrabiblios astrology were shaped both disciplines in the Greco-Roman War. The divergence of astrology and astronomy started in the Renaissance and scientific revolution. Astronomy began to separate, it began to separate from astrology. Copernicus, Galileo, Kepler, and Newton pursued evidence-based mathematical explanations of celestial phenomenon. Astrology, lacking empirical support, became a pseudoscience, while astronomy became a natural science. While astrology is no longer scientifically influential, it still indirectly affects astronomy today. See if this goes up there. Okay, we're moving along.
You're still on that same screen.
What's that? It's supposed to move. It did. All right. Now, the key contributions, the zodiac system developed by Babylonian astrologers, it became the framework still used in astronomy to divide the ecliptic. It divides the sky into 12 sectors, each associated with a constellation and corresponding astrological signs. These signs are used to interpret personality traits, horoscopes, and other astrological information. The Ptolemaic model, Claudius
Oh, it's
Ptolemy.
Mike Cato.
What's that?
Oh, I'm sorry.
Somebody came in there? Well, go ahead, you can finish. All right, anyway, Ptolemaic model, the Claudius Ptolemy's Almagest and Tetrabiblios, the astrological, are key works shaped both disciplines in the Greco-Roman. The Ptolemaic model, also known as the geocentric model, was widely accepted as astronomical model which was developed by Claudius Ptolemy in the 2nd century. It placed the Earth at the center of the universe, with the sun, moon, and planets all revolving around it in circular orbits. To account for observed phenomena like retrograde motion, where planets appear to move backward in the sky, Ptolemy incorporated epicycles, smaller circles on which the planets moved, and deferents, larger circles on which the epicycles moved. The complex system detailed in his dominant cosmological model for over 1,300 years. This video explains the Ptolemaic geocentric model of the universe. There's a video. It goes with it. We're not going to do that at this point. Okay, the divergence of astronomy and astrology. Starting in the Renaissance and scientific revolution, astronomy began to separate from astrology. Copernicus, Galileo, Kepler, and Newton pursued evidence-based mathematical explanations of celestial phenomenon. Astrology, lacking empirical support, became a pseudoscience, while astronomy became, as was said before, a natural science. Astrology's lingering cultural and educational impact. While astronomy is no longer scientifically influential, astrology is no longer scientifically influential, it still indirectly affects astronomy today. First, for the public interest and awareness, astrology often serves as a gateway to astronomy. People intrigued by horoscopes may later explore astronomy more deeply. Popular culture coverage of astrology raises awareness of celestial bodies and terms such as Mercury retrograde. There's also confusion and misconceptions. Astrology can spread misinformation about celestial mechanics. The idea that planetary alignments cause personal changes. Astronomy educators often need to clarify the difference between astrology and astronomy, and I can't tell you the number of times I've had to do that. And most of you that are astronomy buff, raise your hand, as they say. A summary of astrology's effect on astronomy. First effect of astrology on astronomy, historical development, stimulated early observation tools and sky mapping, and scientific advancement, indirect prompted need for accurate celestial predictions. And the modern impact is the cultural influence fosters interest, but also confusion. Throughout early history, country leaders and rulers often relied heavily on astronomers who frequently also being astrologers to guide decisions in politics, religion, agriculture, and warfare. Predicting celestial events to demonstrate power, leaders used astronomers to forecast eclipses, solstices, planetary alignments, which were seen as omens. Stage public demonstrations of this knowledge to impress or control the populace. An example, in 1504, Christopher Columbus used a predicted lunar eclipse to intimidate Jamaican natives, many of you have probably heard this before too, by claiming he would take away the moon if they didn't continue feeding his stranded crew. Pretty cool, huh? Making political and military decisions. In many cultures, astronomical knowledge, often blended with astrology, influenced war declarations, coronations, and treaties based on favorable celestial alignments. Timing of battles chosen based on astrologers' readings of the stars. For example, ancient Chinese emperors consulted court astronomers before making key military moves. Another example was Roman emperors, including Augustus, relied on astrologers to validate their rule. Agricultural planning and calendars. Astronomers were essential in developing accurate calendars, helped determine the best times to plant and harvest crops, crucial for a stable food supply and taxation. Egyptian astronomers used the rising of Sirius to predict the Nile's flooding, a vital agricultural event. By the way, Sirius is the brightest visible star to the Earth. Legitimizing divine right and rulership. Celestial events were interpreted as signs of divine favor or disfavor. Kings claimed to be chosen or guided by the stars, with court astronomers validating such beliefs. Mayan kings used astronomy and rituals to connect their rule with cosmic cycles. Founding cities and temples. Many ancient cities and temples were aligned with celestial bodies based on advice from astronomer priests. Example, the layout of Teotihuacan, I could never do that word, look at it and read it, and Angkor Wat shows astronomical precision. Another example is ancient Chinese capitals were often placed according to feng shui and astronomical observation. How leaders used astronomy. The purpose role of the astronomers is an example, predicting celestial events, eclipses, comets, solstices. Columbus and Jamaica, for example. Political and military timing. Picked favorable dates for major events, Chinese, Roman, and Indian courts. Agricultural calendar systems created planning calendars, predicted seasonal shifts. Egyptians and Mesopotamians, religious legitimacy, interpreted signs as divine approval or warnings, and Maya and Incan rulers did that. City and temple planning determined cosmic alignments for sacred architecture, and that's again Teotihuacan and Angkor Wat. And that pretty much tells the story. Now, I want to add a couple of little things because I'm still in my 20-minute frame. I was always one of those.
Use the mic.
I'm sorry. I was always one of those, as an astronomy buff, to criticize astrology because astrology is not a science, as we know. However, the astronomers like Galileo and several of the others got paid by the royalty to do these things. And that way they could go build telescopes or do whatever they're going to do. And astrology was really very, very important to astronomy. Now, astrology is based on the plane of the Earth's orbit, the ecliptic it's called. It goes right through the sun, okay? And there are 88 constellations, but 12 zodiac signs. And the 12 zodiac signs, just for your edification, are on the outside of that ecliptic. Now, all the planets are pretty much on the ecliptic as well, and they move through these different signs. So they say it's in Leo tonight or something like that. You can take a look at it, and when you see that, you can take a look at the constellation as well. So it teaches us a little bit as well. And oh, by the way, when all the planets were supposed to be very close, they're still on the ecliptic. They don't change their positions. So in fact, they were close because they were lined up on that. Do you have any questions at all? Good. We're good to go. Thank you very much. And I'm going to quit Keynote right here for you. And you're right back where
Yeah,
you
my
were.
nephew was at my house a few weeks back, and he mentioned you're on the Warren Astrological Society. And I'm like, tell me the difference between astronomy and astrology. He says, I thought they were the same thing. Then
We should buy that website.
so, and I told him, astronomy is the natural science of the study of the cosmos. Astrology is the belief that the position of the moon and stars and planets at the time of your birth and throughout your life affects your life somehow. He's like, oh, so.
I want to do something for you. Go ahead.
Yeah.
Keep talking. You don't need me for this.
But anyway, so we are on our lunch break. That takes 20-minute snack break, and we will be back. What time is it? 7:42. So just after 8 o'clock. So go get a bio, go get a munchie, go get a drink, and be back at 8 o'clock for the feature presentation.
There you are.
All right.
Okay. Thank you.
Thank you. Good job. I'm going to, for when Adrian is
Do
doing
that,
it,
yeah.
I'm going to aim this at him. I don't know where we're gonna make him. You can't move that because it's all plugged in here.
Yeah.
Can we set it here?
Sure.
And aim it at him?
Absolutely.
All right. We'll do that then.
Yeah. I want to do one more thing, though. I have a plug that I want to get in here and make sure that this thing is charging.
Yeah. Oh my
That's what I want also.
August,
What are you looking for?
Here.
So I wonder when the administration is going to have White House astrology. So from what I take is that astronomers were actually listened to until the Industrial Revolution. Then all scientists, nobody listens to them at all. You've heard the saying, every disaster movie starts with a scientist being ignored.
I know it's here.
Yeah, I know.
Trying to find out what I did with that, and I don't know what I did.
With what?
Going to my thing. I don't think I'm going to need it, but it is here somewhere.
It's not this one, is it? What kind of cable are you looking for?
That's,
USB-C?
those are,
That was just sitting there the entire time.
yeah, that's to just go into the
Oh, okay.
system, but that's not the one that I actually want. And, get me a little crazy. I got it. I got it. But you can't get it in there. What? You can. Is there another plug over here? Yes, that's what I want. This is what I want. I found it. Yes. What's that? Never change, pal. Why are you not doing this? Okay. I guess if you do it this way, it'll be okay. Right? And it's not lit up. Why is it not lighting up? Isn't that something?
Well, you know, it's a Galileo. Yeah.
This is not working. That's weird. This is not working.
Matter.
That is not, that should be working. It's not working. I don't know why it's not working. I don't know why that's not working.
How are you? How are you guys doing? Yes. I'm gonna put this on my new
Okay. Oh, I see what's going on. I see what's going on. Okay, that didn't work. That's crazy.
I saw something burning this you have the structure of the thing you're that.
They would leave a note on the door saying maybe.
I asked them outside, it was very specific about size. And
I don't know why it's not working.
What's not working?
I'm trying to get this, I plugged this baby into here, and then I plugged this into there, but it's not getting any power read over it. And that's what's bothering me, is it's got to do that.
what's not on there?
not doing it. Isn't that something? Wow. I know this is working. What? It's charging, but this is not charging me for some reason. And I have no reason why to believe that. What I'm doing is I'm plugging this in here and this. It should power this, and it's not doing it. And I plugged that other one. I'm wondering whether this thing is working at all.
I was gonna say, is it on?
And I can't get in here because that doesn't give me enough room. It's working, but I think that this one is not working. Just not doing it. This should be charged up.
So, do you have a little battery scroll bar that tells you how if it's charged?
It's not doing it for me. There is one other option. One other option. One other I have one other option. It's just not doing it. It should be, this should be lit up right here, and it's not. Watch this.
Power bank?
Watch this. But this will work just fine. Absolutely. And it's working. So my little battery is working, and this one isn't. We're cool.
Okay.
Okay. That's interesting. It worked. Oh, absolutely. Yeah. No question.
I went all the way up to no, I went down here. I couldn't do it. Somewhere close to 20. This one, did it again. Oh, yeah. The name was it was Canada. How far from Sarnia? This is the one I showed. This northern light above is Camden. A little further south is the zone. Maybe more than 2024. The outburst is so big. It stood as your face
Five-minute warning. There we go. Jesus. What a mess here, Ken.
Where should I stand? Perfect.
Yeah, I gotta get rid of the background.
I'm melted. All right. I'll bring these things in.
Yeah, there we go. Look at that.
Oh, cool. All right, that works. I'll work from here.
All right, look at that. Ready?
All right. Bob.
Oh, yeah. Okay, yeah. Bob, why don't you come up and do this? What a mess. There you go. There you go.
Okay. There's a lot of our members that use the W.A.S Air to control your telescopes, and I'm going to try to save you a wasted night. Don't go out and try to use it and before you update the firmware on it, or the operating system for the ASI Air. The last one they had some major bugs in it. It didn't plate solve. It didn't a bunch of other things that it was supposed to do. It wasn't going right. What you need is the latest version, which is 2.4.1.12.35. But all you have to remember is the one that the last number in that series is 35. And it was just out today. They just put it out today. caused a lot of problems. A lot of people had major trips for astronomy ruined because their equipment would not work. So before you use it, get it updated.
They didn't want to look up and actually see the sky either, so I'll cover that in my presentation.
All right.
Ready?
All right, go for it.
Okay. Tonight, we're privileged to have Adrian Bradley as our main speaker. He is not only into amateur astronomy in a major, major way, but I think he has, at least I've heard him give talks on landscape astrophotography. I don't know exactly what term you would use to describe it.
Several. Milky Way photography.
Milky Way photography. I just talked to a newbie in the audience who didn't know what the Milky Way was. Okay, so
Come see me after the presentation. I'll tell you all about it.
So, Adrian is involved with the Royal Astronomical Society of Canada, the Explorer Alliance. I don't even know what that is.
Explore Scientific's got a group of us. We do a global star party. Almost every Tuesday, we do presentations online. It was a COVID thing that kept going. It's a global group of folks that include both professional and amateur astronomers giving presentations.
Can the people online hear what Adrian's
Hear a
saying?
word I just said.
Right.
So the short version of what I just said is there's a global group of both professional and amateur astronomers that do presentations online for a global group, usually Tuesdays starting around 6 Central or 7 Eastern. And the lineup has included David Levy. I don't remember if it's included. No, it has included brother. It has.
It has. He was
Brother
on
Guy
once, yep.
Consamano has been on Global Star Party. David Eicher, editor-in-chief for Astronomy Magazine. Other astronomy dignitaries, and not only from North America, all over the world, South America, Switzerland, New Zealand. There are astronomers from all over that give these talks. And it's more than an honor to be a part of that group.
Okay.
Carry on.
There's quite a list here. Adrian is also in the Astronomical League, the University Lowbrow Astronomers, G.L.A.A.C, Great Lakes Association of Amateur something,
Astronomy clubs.
astronomy clubs, and of course, this erstwhile organization. Something I didn't know also is he's published 3 articles in Astronomy Magazine. Pretty
I'll be
impressive.
happy to tell you about those.
So
And it wouldn't have happened if Doug Bach hadn't sparked my interest in doing imaging.
yeah.
So give Doug Bach a hand for leading to that.
So Adrian's talk tonight is a sort of a generic title, Astronomy 101. He can take that a lot of different directions. But I hope that people who are new in the hobby here can really get something out of this. And Adrian, how are the people online going to hear you?
I'm going to increase the mic sensitivity
Okay.
on Zoom.
Okay, and I'll end up talking over here.
Okay, I'm going to aim you over at him and increase the sensitivity on the mic. So
Right.
give me a second.
So how many of you, I'll go ahead and, well, I should give you a second so
Oh.
you can put me on camera.
What happened?
I can see me over here,
Crying out
but your
loud.
connection to the screen is probably gone.
Restaurant.
Which is okay, because I'm not gonna use the screen. While we're connecting that, who here is new to the world of astronomy? Good. I'll be looking in your direction most of the time. You're not new to the world of astronomy. Who here is new
Did that come out?
to the world of telescopes? Knows nothing about, would love to learn a lot about it. You too, Doug. Yeah, you don't use telescopes anymore. I'm sure you would love to know what they actually do. All right. Just remember, look. Here, we're gonna start real simple.
Well, you know what?
This
I need them to see him.
is
So
an
let me
eyepiece. Everybody look.
Okay, I'm just
Now,
not
the
worried about the
reason I
screen.
do this is today's world, what do you see when it comes to telescopes. We're off the grid right now. That's perfect. That's actually a perfect metaphor for what I'm doing. Who's heard of the sea
Share
star?
screen?
Raise your hand. Some of you that are new to astronomy and new to telescopes have heard of the sea star. And what does the sea star do? You take the unit, you plop it down somewhere, you turn it on.
I got it.
It figures out, and this is a generalization, figures out where you
There
are
it
in the
is.
sky, points at something you want, and starts taking an image.
There it is.
In today's world, we're more about images these days. The ones that saw the beautiful images that Vera Rubin attest to it. When it talks about looking at and enjoying our universe, we're doing it through images. But I'd say 10 years ago, if you came to a club meeting, maybe 10 or 15 years ago, the landscape at a club meeting was very different. You saw a lot more of these telescopes out there. The way to do amateur astronomy was using an eyepiece in these things that we call telescopes. Now, if you're looking at this unit here, which is heavy, you notice there's a camera connected to it. And that's where the astrophotography part of it started going on. And I'll talk more about the requirements to do astrophotography become a little tougher than the requirements for just looking at an object. But we'll go through all that. So what I'll do is I'll start with when you get your very first telescope, if you go and order one online or buy one, chances are it's gonna be a small instrument like one of these, but this would be connected to a different mount and have an eyepiece in it. The simplest telescope that you should get if you're interested in looking at the cosmos directly would be one like this. So the type of scope is a reflector. Just store that away. You can look it up online. What is a reflector and what's the focal length of a reflector versus a refractor versus a MacCas or Mactasoff, Cassegrain, any kind of Cassegrain type telescope. All the experts in here know what those words mean. Those of you that don't worry about it. So looking through a telescope is very simple. You can go up and down this way, and you can aim at whatever it is you want to see, preferably not that bright light over there. And you look through the eyepiece and you get focus. Now, one thing I recommend with your telescope, you get your first telescope, you set it up, get something simple like this that connects, tightens. This is a slow rotator. You'll see some of these where you can move slightly, or you can try moving it by hand. First target you should write down in your notes should be the moon. Why the moon and not M51, some sort of galaxy? Well, unless you know the night sky, the moon is going to be a lot easier for you to find. Planets can be next, but I'm going to warn you, with most beginner scopes, planets are going to be about as small as the little dot appears in my finger right now. You can still pick out some detail. Some of these types of scopes here, these little scopes that provide a more narrow field of view, will still show you planets a little bit better, but these are, when you're talking price of scopes, the bigger these are, the more the price starts to go up. And that I'm not including my camera here or this mount that it's on. These scopes, your average scope price these days, if I recall correctly, and you all can correct me, you start at $400 for a basement bargain, really cheap scope, and you go up to $600 or $800. With telescopes, the bigger the mirror, the more light it will gather, and the more of an optical image you will see. So when you take your telescope out in your backyard and you've got a lot of towns around you, and you wonder why it's so, everything but the moon is faint, light is fighting its way through other light. We sometimes call it light pollution, light from cities. It's not as good a picture in your scope that you may think. So there is a learning curve when it comes to using telescopes. This is Telescope 101, so we're getting right to the basics. A finder, where you turn this on, the dot should point to where you want to look at in the sky, and then when you look through the eyepiece, that object should be in the sky. Coming to one of the star parties, the W.A.S star party, which when the next one is a good way to bring your new telescope and have someone take a look at it and make sure that it's working. There's also something called collimation. Collimation is for astronomy telescopes 201, not 101, but the idea behind it is your mirrors need to be aligned in order to get the most focused picture you can get. So basic telescope, I see an object right there, I see a star, I point at it, I go to look at it in the eyepiece, and I make sure it's tall enough for me to see. Now, if you're not tall enough and you can't get to this eyepiece, you will need some extra equipment in order to enjoy your telescope. One, you can always lower the legs here, or you get a small little step ladder to put here so that you can step up. If you are challenged and you get vertigo a lot, don't get the step ladder. We have it's story time. Some of these telescopes can get huge. We had one person, gentleman by the name of Mark Depressed. Doug, you may have heard the story. At some point, he's up on a huge ladder because some of these telescopes can get to be really big. You've got mirrors 30 inches in diameter and as tall as the sky itself. We had Mark Depressed way up there observing something. He loses his balance and he falls. So telescopes can be dangerous. Go get a sea star. Doug, you have a question. I ask questions throughout this presentation as often as you want. Huh?
I have a comment on the ladder thing.
Yes.
I had a 20-inch F5 obsession dot.
And I'll explain that in a minute.
In the 90s.
Uh-huh.
And I sold it because I fell off the ladder at 2 o'clock in the morning more than once.
Yeah. And he turned into an astrophotographer the very next day. So that's why you should be careful. Now that's serious. He's still with us, but anytime what'd you say you had a 20-inch F5 obsession? Yeah. Let's talk about that class of scope. 20-inch, so the mirror is about yay big. Remember we said the more a telescope gathers light, the bigger a picture you can see. His was 20 inches. It probably came up to double my height as far as the tube, this tube here. This is the optic path of the scope. It's an F5, that's
100 inches.
100 inches from mirror to the secondary or to the edge of the,
To focus.
to focus. So 100 inches to focus, which someone do the math and make that into meters or feet. Long way. And so the larger your scope,
8 feet.
8 feet. So I stand at about a little under 6 feet. His optical train is all the way up to here, and the rest of the assembly is large enough. For Doug to fall off of that a couple of times is not it is significant. So telescopes can be dangerous, get a sea star, or keep learning, where we'll talk about some of the other telescopes I have here. But as far as the picture goes, now who's heard of the Horsehead Nebula? Good. You can see that. I'll just say this. You can see the Horsehead Nebula directly with your naked eye, with the right eyepiece, right filter, maybe even not need it if you're in the right skies with that telescope Doug had. Imagine looking in the eyepiece and actually seeing the horse head. We all know we can, and I've done it myself, we can image it with the refractor, the smaller unit, we can image it with a camera. We see it directly with his class of telescope. And that's where the telescope boom from 10, 15, how many, maybe 20 years ago, it was all about aperture. Everybody was buying those bigger telescopes because as of yet, astrophotography was in the hand of big observatories. There were glass plates with surveys of the sky. You had to be at major observatories with their cameras. They were observing and imaging the sky. As of yet, you're talking film cameras. A few brave souls tried to take pictures. Most of us wanted to look at it directly. And if you have a small instrument like this, or even this, you're not going to see very much with that small mirror, even if you go someplace very, very dark. So we'll get a little bit technical here, and then we'll start demonstrating the go-to mount, which is Astronomy 201 as well, but we're going to show that off because if you get that working, it can greatly add to your observing experience. You can plug in an object you want to see, it goes to it, and then you can look at it and see how much of it you can see. And it stays on it because there's tracking. So, all right, so let's talk about sky quality. So one of the things, we talk about telescopes, you say, yeah, I have my new telescope, I'm gonna go out here and I'm gonna look. You try and look at some object, let's say the Dumbbell Nebula, whatever that is. If you click this button on a sky quality meter, and you get a number like 19.59 or 20.1 or something, and you're looking, and it's like, I can't really see the Dumbbell Nebula. You go to a place that's dark enough, and you click this thing, and you get a 21.4, a 21.5, or outside of Bryce Canyon where I was, 21.7. The Dumbbell Nebula had color in it, looking at a 2.5-inch little scope. Darkness matters with a telescope, and that was always the other thing with the telescopes. It's fine to have a nice, snazzy, expensive toy, but without the dark skies, you're not going to see very much. Ken's nodding his head, and I just want to, Telescope 101 teaches you dark skies, aperture, and a good eyepiece with a lot of contrast are the three biggest things that telescope owners tried to get right. Now, electronics and go-to and push-to and all these other things simply make observing easier. There's a fourth thing, knowing the night sky. I recommend everybody get, either on the phone or in paper, a star map application. I use Sky Safari Pro. There are many others, Stellarium. If anything else, look up a star map. What's up in the night sky? Application, put it on your phone, your tablet, and you can start looking at it, and it'll point out objects that which, if you don't have them connected to your telescope, again, that's 201, connected to your telescope, you can at least say, okay, the Big Dipper's right there. Actually, the Big Dipper would be right here because this is north. Big Dipper's over here. I know that there's a galaxy right over here. I'm gonna try and find it. And you turn on a laser and you can look through there and you go, I'll see it. When you go to a place out west of Mississippi, or let's just say you go to Michigan and you go up into this area here, or you go into this area here, or you're on the western upper side of the state, or you're in the upper peninsula, which you go up there, you might see faint fuzzy object in there. Now, in the world of Hubble images, JWST, Vera Rubin, if you're not used to the world of observation, you might go, okay, I'm gonna go buy a C-star. Because the image is only gonna be a smudge. The object with observing through a telescope is how much of that image can you see, can you detect, can you even detect it at all? These are photons coming from that deep space object, millions or trillions of light years away, depending on what you're looking at, and they're ending up in your eye well and not the eye well of a camera. Telescope observing is about a personal connection to the night sky. And if you know how the night sky works, what's in the sky right now, how is it going to roll over to the north? And it goes this way. How is it going to roll over in the south, which is what we're facing, at this latitude? And then you hop in your car and go 25 hours to the west, and you can see a little bit more over here or a little bit less over there. That's all a part of the chase of using a telescope. For here in Michigan, my recommendation would be to go for the brighter objects, start with the moon, go to the bigger planets like Jupiter and Saturn when they're back out. Mars will look like a little red dot. Of course, it depends on the type of scope you've got. The bigger the focal length, the more detail you may actually pick up. But start small and easy. Go to star parties where you've got the larger telescopes. See the difference in the objects and how they look. Somebody brings out this little 2.5-inch thing and they're looking at something, and then someone goes with that 20-inch obsession and they're looking at something. Notice the difference. The eyepiece matters. The smaller the number on the eyepiece, the more narrow your, the word focal, I want to say focal length. Field of view. I do have help out there and I use it occasionally.
What about the light pollution filters? Have you had much luck with those?
You can, yeah, let's try not to kill myself. In this box, there are things called filters. And for observation, somewhat advanced observation, yeah, you want to use filters. There's cold-free filters, there's light pollution filters. What you do is you would take that filter out of here and you would screw it on to, and you get a 2-inch filter if it's a bigger eyepiece, or the 1 1/4. These are standard sizes, and your new scope's going to come with something like this. Screw it on here, and now that light, it blocks all wavelengths of light that are normally associated with light pollution, like tungsten. Some of the new lights that are being installed, the LEDs, aren't being blocked by that. So light pollution's more of a problem. You have to, you end up having to observe in narrowband. So oxygen 3 is a narrowband filter. I know there's a much better meaning that I could give you, but narrowband filters like hydrogen alpha, space emits light in hydrogen alpha, oxygen 3, I want to say sulfur 2, but so these narrow bands, and if you cut out all of the light, you get a filter that cuts out all of the light except that, then you see structure from that object more clearly. But if it doesn't emit in that light, you basically make it invisible. So,
a beer can? Eyepiece?
a beer can?
Yeah, got a big eyepiece?
I do not. I am getting one soon. It's on order.
Tell them what they are. Eyepieces are different.
Okay, so I think if you're talking about the eyepiece that's, yeah.
Literally about that big.
Yes.
The eyepiece is about that big.
So you're talking eyepieces that can cost you between $400 and $600, or even $1,000, depending on the make and the model. Teleview Nagler is one of them. So if you want to spend money on this hobby, get a giant mirror. Yeah. And it goes like this. If I could draw it on the board, I would. Visual astronomy. You're $10,000 in before you fall off of the ladder and realize this may not be the thing for me.
There's another factor that.
Yeah, go ahead.
When you talk about looking at the planets, for example, it also has a little bit to do where they are. Meaning they could be close to you. For example, Mars could be as close as 35 million miles away. That's pretty darn close. And you get a pretty good sized object, even in the smaller scopes.
I've seen some details on Mars with a 6-inch scope.
Exactly.
I think it was an F10. F10 is much like you. Who's a photographer in the house?
I am gonna say I'm guilty. I have never understood F ratio.
All right, we're going to talk about F ratio. This is not a 100 level course, but we're going to talk about it as if it were a 100 level course because that's my understanding of it too. F ratios or f stops in photography turn out to be the same in telescopes and in lenses in cameras. So you've got the focal length. I think you were talking about the length of, the focal length of the optic train. Say again?
The focal length of the primary.
Of the primary.
Yeah.
There's a certain length by which things come into focus.
And it's fixed.
Based on how you make the mirror.
Yep.
So you were saying F5?
F5.
Some mirrors are F10, F11, so those focal lengths are a lot longer. The math is whatever the length is in millimeters, inches, whatever, divided by the diameter, the aperture, diameter of the mirror. So some of these scopes are twice as long. When Mars is close, you see them pretty well in those scopes. You may not see the Andromeda Galaxy as well, or some of the other faint objects, but you may see,
See things like Neptune and things.
yeah. So you can think of it as the type of scope that you get for planetary. You want to look at Jupiter and you want to see the Great Red Spot. Longer focal length for you means, and then let's see, I have an 11 millimeter eyepiece. The lower the number on the eyepiece, that's the
Power.
It amounts to the power.
It's divided by the size of the mirror also.
Yeah.
Length divided by the length of the middle.
Yes,
That's
so
the magnification.
that's the math. The idea is the lower the number, the longer the focal length, the bigger the power,
Right.
which is basically a magnification power that you're seeing. So that's going out, pulling in a picture, makes it appear closer. For planetary, bigger focal lengths and smaller numbers on your eyepiece, like 11 millimeter, 10 millimeter.
So you
Good
could
for
use-
plants.
You could use that eyepiece in both of those telescopes back there. The image would look different.
Yes. That's an F6. This is probably an F6. So actually the image may look similar, but with the wider mirror, it may be brighter.
Focal length is what makes it.
Yeah,
different.
Yeah.
Length divided by the length of the eyepiece.
Right, so your picture might be the same, but this one's gonna give you a brighter picture. You may be able to see more because you've got a bigger you've got a bigger mirror. So go get a C star if you don't wanna worry about anything. Yeah, if you haven't learned anything else from this presentation, go get a C star. All right, we're at 8:30. So let's talk about some of the ways that telescopes have stolen our ability to look at the night sky and instead go to a camera. Now, there is an advantage to doing so. You live down here, or you live near a big city. You'd love to observe these objects in your telescope, but hauling out a 20-inch obsession just doesn't do anymore. The back just can't take it, and you lost your ladder. So, what do? What have I been saying for this whole presentation? Get a C-star. Small little portable thing. I didn't, but I brought an equivalent. Oh, God. Something that works very much like it, except you have to polar align it yourself. Now, there's no camera on there. Pretend this is a camera. Maybe, you know what, I could probably, nah. If I stick a camera in the back of it, then it acts like a sea star. So, what I want to do is show off what these things look like when they're in action. I have a much smaller power unit for this, and I have batteries. But in the olden days, you brought things out this big to power if you ran electronics in your telescope so that it would automatically go to things you wanted to look at. You ran things like this. And if you ran it from your car and your car ran out of juice, you had one time to power it up before you were just stuck there. So what you did is you just observed till the sun come up. Observation is an all-night thing. So, all right, so we're gonna turn this on. So you have your Alt-Az mount right here, and you control it, you point it where you want it to go. This is an equatorial mount, and equatorial mounts are designed so that they follow the Earth's rotation. And the ecliptic. We just had to talk about the ecliptic. You want to get into astrology, buy one of these mounts. Wherever it points, make up a story about someone's relationship, and you will do very good astrology.
Adrian.
Yeah.
What kind of telescope is that little one?
This little one is a 2.5 inch, it's a 70 millimeter, it's a little refractor. It's basically like a lens. You hook that to a camera, it's like hooking your birding lens to your camera and taking a shot. It's a smaller refractor, it's a nice clear picture. It's usually the choice of astrophotographers, but you can observe with a small scope like this. A story is forthcoming. Being out near Bryce Canyon.
That's Galileo's telescope.
Essentially Galileo's scope. And as it goes, as dark as it was in Galileo's, he was able to spot moons in Jupiter with a scope this size. I was able to spot about,
It was like
Aperture, half an inch.
so in this scope, where I was, where it was dark enough, I was able to spot about 13 objects in 10 minutes. And some of those objects had color to them, like the dumbbell. The dumbbell nebula is a good benchmark object for how good your skies are. If you see a smudge, it's kind of mediocre. If you barely see an apple core, it's starting to get better. If you see a football, you're at least looking through, you're probably looking through a slightly larger image, or you're an even darker sky than I was. You start seeing color in it, whether you see the full football or not, you know that you're in a pretty dark and transparent sky. All right, so portable setup, I've got something smaller than that to run this. So the way I do it is I connect alignment. So this gives me a number of stars that are up in the sky right now. Let's align on Vega. So we begin alignment, and the scope magically moves. And this is go-to, and this is what go-to looks like. So it's aligning on Vega. Where that stops, Vega will approximately be where it's pointing in the sky. And you can always adjust it to get it spot on. You look through your eyepiece and make sure you see the bright star.
Vega is the fifth brightest star in the sky, and in the summer sky, it's the second brightest. Okay?
Yes.
It's part
We're in the
of
summer sky right now.
Right.
Brightest star is Arcturus. I was going to say Arcturus. Now in the winter sky, Sirius takes over,
All over.
and then below Sirius is Canopus, which you can't see, the third largest, but you're in the northern hemisphere. So go to the southern hemisphere with your C-star if you want to see all of that.
Now notice he's controlling that with his smartphone. Before smartphones, a lot of these had a controller.
Well, yeah, you had to attach your
Oh, man,
electronics.
it's an awful controller with LCD display, and
It looked kind of like this, but it was a controller.
But to use.
Yeah. So be glad you're in the world where they built these things out. You can control them with your smartphone. You know what else you can control with your smartphone?
A C-star.
A C-star. This is how the talk went at AstroCon. He sold the C-star because it was how to choose a telescope. What it really was how to choose a C-star. But you notice there's no C-star up here.
By the way, you will manually try to make sure you're on data with that scope, but with the C-star, it does plate solving.
Yeah. Let's describe plate solving. When you have a telescope, you're the plate solver. You go, that's the North Star, that's Kochab, and the other one, the Guardians of the Pole. There's the Pointer Sisters from the Big Dipper. Okay, that's the North Star. I'm going to look, and that's all over here. I'm going to make sure it's centered, aligned to this polar scope. And when I do, my chances of the go-to actually hitting the object I want to look at are a lot greater. That was your polar alignment. What do you do with a C-star?
Turn it on.
Beep, boop, beep. Figures out where it is in the sky. It does the plate solving for you. I recommend you learn how to plate solve as a human being. That constellation, what are the stars, star names, this constellation, stars, star names, and when you start out learning the sky, you can then cross-check even your C-star to make sure it's pointing in the right location. You always, whether you're using electronic equipment or is that what it's supposed to be and you have no idea where you're looking at, if you start with a constellation you're familiar with and you look at things that are within the constellation, your star map will do that. So, one thing you do, solar system. Let's see where the moon is right now. So, this demonstration would work a lot better outside because I think it's up right now. And what you can see is the scope. This is declination, and that's right ascension. I always described it as declination and right ascension. The combination of these two movements allows a scope to point at anywhere in the sky, but you have to line it up. And that's lined up. Says the moon's rising in the east over there. It's probably reasonably accurate. That really is north, so it's pretty close. Well, what if I want to see a galaxy? Sure, why not? So let's go to a deep sky object, and let's look at Messier 51. Who knows what Messier 51 is? A whirlpool. It's not up yet, so it won't let me go. Let me think of what does
M13.
M13. Anyone know what M13 is and why Omega Centauri is better than it? It is the third largest globular cluster in the sky surrounding Earth. The second is 47 Tucanae in the southern hemisphere. The first is Omega Centauri, which sometimes barely rises high enough with the Centaurus constellation to the south, best seen high in the sky in the southern hemisphere. The lesson is go to the southern hemisphere and take your C-star with you. You'll see way more stuff. So what did I point at? I pointed at Messier 13. So should be up there somewhere. Let's see, let's point at one more object. The Lagoon Nebula is Messier 8. Notice how I seem to know what the objects are. We don't, in some of these programs, you don't always have a picture saying it's this object. So getting a list of Messier objects is good, or with Sky Safari, it can show you what's in the night sky, and then you can try and go to it. This is the Lagoon Nebula, and it's near and dear to my heart because it's in the middle of this thing called the Milky Way. And so right now, the Milky Way is also rising. Now, the moon was over there. This thing is going to be so low to the horizon. So right now, Milky Way is sitting like this.
Which one are you looking for?
Messier 8, the lagoon. So yeah, Ken's looking up to see exactly where it shows up in the star chart. It's right on the horizon. You can tell how flat this is. So if you get GoTo working, which is Astronomy 201, but if you get it working, it can teach you the night sky. You can go, I want to know where this is, and it can go there, and you can go, oh, okay. The longer you stay outside with your instruments, the longer you notice the sky moves. So different objects are going to rise at certain time. I want to say, and I'm actually going to figure that out, the Pleiades. Who knows what the Pleiades is? If you've ever seen it, the Seven Sisters, that little cluster that's naked eye visible.
Taurus the Bull.
In Taurus the Bull.
And you can see it with the naked eye.
Yes.
Put on a Subaru.
Also known as the Subaru.
Subaru.
Who owns the Subaru?
Subaru.
You own the Pleiades. And
The Seven Sisters.
yep. Who knows the Messier designation for all you advanced astronomers out there? What's the Messier? M45. Yeah, it's also got another name. So let's see where it is right now. Yeah, it's low on the horizon, but with your apps, I'm showing you this and you can't see it. So with your apps, you can go an hour or more and find out that it is above horizon 3 o'clock, 3:42 in the morning. And if you shrink this, you can see where the sun is beginning to rise and the Pleiades does break the horizon. There's tonight. Ken's got a picture of it. Part of knowing the sky and knowing what you want to observe, and the Pleiades would be your second best object to look at in your small new telescope, because it's a bunch of bright stars that'll fill the view of the eyepieces that you'll usually get with your 25 and 10. 20, use the 25 millimeter one, and you'll see those bright stars against the, whatever color of the sky you've got. And that's a good object to look at after the moon. And objects such as Caroline's Rose, NGC 7789, or the Helix Nebula, NGC 7293. Yeah, those objects come with Astronomy 401, or if you spend the money on at least an 11-inch aperture instrument and you go someplace really dark. If you've heard of the Veil Nebula, that's also something you can observe.
He's got great images of that.
Yeah, you can get great images of the Veil Nebula. You can see it with your eyes if you're close enough, if you're somewhere dark. Starts at some place like Boone Hill, which is somewhere over here. Like I said, anywhere up here and on are places where you begin to see the some of the fainter objects. And with the filters like you were talking about, you can separate that light so that you don't have to be in as dark a location. You put the filter on, you can still see it. But for your smaller instruments, large, bright objects, as soon as you start getting bigger telescopes, you can start looking directly at the faint objects. If you sell yourself out and you get the C-star, you can look at just about all objects, but you still have to know how large those objects are. And if you don't, you'll find out when you try and look at them or image and you don't see much. Your homework is M33. One of the pinwheels, I think. Right. There's like 2 pinwheels. And M101 and M33 are 2 galaxies in the Big Dipper. You want to know if your skies are dark enough? Figure out where you are. Figure out where they are near the Big Dipper and see if you can observe them with your telescope. If you see a faint, that's in 33, he's showing them over there. If you see a faint fuzzy patch, congratulations, you see it. If you're someplace out west in the Oklahoma Panhandle or further out, you start seeing the spiral arms in smaller instruments, and you start being able to do things like count H2 regions. Jeff's not here to talk about the advanced observing that will come in Astronomy Telescopes 401, what to try and observe. You have sketch artists that will draw what they see, and if the higher your altitude, the better your transparency, and the better seeing. Those are terms that you hear astronomers brag about knowing. But what it means is your picture in your eyepiece gets better. You can stand there and look at the sky like all the astrologers of the 17th, 16th, and on century, and you can start looking and seeing things naked eye. I do recommend, if you ever get out one time to someplace really dark enough to see something going across the sky that looks kind of like a cloud. When you go to places dark enough, this thing we call the Milky Way becomes so prominent, you can't miss it. You're going, what's that? And if it's dark enough, you not only see it during the summer where you've got the bright core, you start seeing this thing go by Orion. And if you've ever looked at Orion, all you saw were stars, right? Hey, I see Betelgeuse, and I say it 3 times. The other shoulder, Safe is down here, Bellatrix is up there, Rigel is down here, there's 3 stars for the belt, and there's this sword. Yeah. Go to a dark sky and see if you can find all of that. You might see the main stars, but you'll see a vest. You'll see a bunch of stars over here in the corner. You'll see more stars surrounding the area. You'll definitely pick up the sword. You'll pick up all the stars of Betelgeuse's head. You may pick up Taurus. You're going to pick up something shooting right next to Orion. That is the winter Milky Way. So there's a lot to see in the night sky. Once you can pick it up visually, your telescope is going to show you, almost no matter what your size, even in a 2.5 inch. Essentially, that's what I was doing out there near Bryce Canyon, was going, let's look at this, and then I was observing it in that little 2.5 inch.
Adrian?
Yes.
How do you take about 1 minute and mention solar telescopes?
Solar telescopes. I didn't bring my solar filter, or that would have been real easy. Pretend this is a solar filter. Solar telescope. You can buy a white light filter and turn your scope into a solar telescope. Or you can buy these things called HA blunt. What they do is they show prominences coming off of the sun. They show the sunspots, but in a different way. You actually also see, and it's something I observed, like the white light from prominences that are facing you. So, correct me if I'm wrong, it's the chromosphere that you see out of the hydrogen alpha scope, and you see the photosphere, you block the photosphere, and you see the sunspots.
That's what you see in white light, right?
You're seeing white light.
But in either cases, only do it with a safe filter.
Only do it with a safe filter.
Yeah.
All it takes, this is your filter. I poke one little pinhole in this filter, and I go to look through the scope, and I don't have an eye anymore because I sat there wondering what went on. Why is it so bright? And I left my eye open.
The sun is bright.
Yeah.
There's your sun.
There's your sun. Now, is that the HA view? Did you show them that, or did you show them the white light view?
I'm showing you.
Yeah, that's the white light view right there. Yeah, so we could have put it on the screen, but this is 101, it's low budget. This is how you struggle with astronomy in the middle of the night when something doesn't work. There's your hydrogen alpha view with prominences, things that are facing you. When it doesn't work, you've got a flashlight and you've got the veteran visual astronomers with the 20-inch session yelling, "Turn your light off!" This is something we have to work on as an astronomy community. You've got new folks that are trying to buy this equipment and aren't sure how it works. We do need a little more patience in the astronomy community for that, because all they're trying to do is get it to work like this so they can observe something. I highly recommend look through another scope and then practice with the bright objects, then come out to the star party and, away you go, and you can get, if they're not yelling if they're yelling turn off your light, don't go to them, go to someone that walks up and says, "Here, I'll help you." And just as many turn off the lighters, there's folks that will help you get going with your telescope so you get some use out of it. But
Something that's really useful is, you showed the Sky Safari.
yeah,
There's a couple other programs like that. If you have a phone that's more modern one, a Samsung or an iPhone or whatever.
yeah,
When you aim it up in the sky, it's got a built-in compass in it. And so it will show you on your screen in real life what you're looking at.
yeah. I don't know if any of you see that.
You can see on there, okay, this is such and such object.
Yeah,
And you can use it to plan around. And using that, you can find out where they all are.
yep. So there's the sun right over there. Now, if the real sun is over there, should you be looking in that direction? Probably not. If there's a lot of smoke blocking the sun, you might be tempted to look, it's bright red. We recommend, and so does the Astronomical League, do not look at the sun without a safe solar filter that doesn't have a pinhole in that cover, or a safe solar scope like an HA scope.
Yeah, the fact of the sun is the entire sun, every point of light on the sun is as bright as the whole sun. So when you're talking about it, even if you block it off a bit, if you look at that surface of it, you will burn a hole in your retina. That will absolutely happen.
Yeah,
What you have to do is you have a filter. The only time you don't need a filter is when the moon covers the sun. And that's what it's known as a solar eclipse. When it covers the entire sun, you look at the sun with your naked eye. Or with a telescope like that, it's fine.
yeah, as long as it has a filter.
As long as it's total.
All right, so here's what he's talking about. If it's like that, you better have a filter.
You have a filter.
If it's like this, you better have a filter.
You still need a filter.
You still need a filter for this. If it's like this, you're tempted to look. I recommend you stay with a filter.
Yeah.
This was about where that eclipse was around these parts. If you went the last eclipse, where you went to Ohio and on down to see totality.
Yeah.
But you saw it like this. Most people look directly up. Not really recommended. Here's the deal. You see the shape of the sun here? Now, it moves pretty quickly, so it may have scared a few people, but you see the shape. Whatever the shape of the exposed sun, and this is, especially if you're looking at it through this telescope, the shape of this exposed sun is the shape of your cornea by the time it's done burning it out.
Exactly.
You see crescents forever. You close your eyes and that will always be there. So you must be careful when you see this.
This is a naked eye vision of the sun.
And just to explain to people, yeah, the moon is covering, you're not actually looking at the sun at that point.
We're not.
Yeah.
You're looking at the outer atmosphere.
And that's called the corona on the outside, like that.
And that's fine, because that's super dim.
That is actually the same brightness as a full moon. Believe it or not. That's what
Go ahead and look at the sun when it's covered by the moon like this.
Yeah.
In 20 years. Yeah, 20 years.
Or if you go to Spain
You go to
in
Spain, you go to
2026 or Iceland,
We're going to Spain.
you're going to Spain. Yeah, I'm looking into it. I just may have to be a stowaway. But when you see the sun like this, you can not only look at it through, with your naked eye, binoculars, your small telescopes, take a picture of it if you want. I took this picture handheld. I just said click, click, because remember, everything, celestial bodies are still moving. The moon, the lunar speed through the sky is a little bit faster than the sun, which is why they don't just stay together.
Right.
If you're deeper into the shadow, they appear to stay together longer. If you're on the fringe, they hit like this light, I eclipse the light, and then it goes away. But if I'm deeper into the shadow, the eclipse lasts longer.
Now, the eclipse cannot last more than 7.5 minutes, total clap, and most of them are 2 to 3 minutes when the sun is completely covered by the moon. But again, that's something you just learn that.
Yeah. And if you have your telescope at the side of the eclipse, look through it, even this little thing, while it's total. Remember the lines you drew in the when you drew the sun in grade school? You always drew those lines. They really exist.
That's right.
You look down in there and you see those lines coming out from where the corona is. You can even see the detail of the moon, the mountains going around the moon. You see a lot of detail. If nothing else, observing the moon, observing the sun safely, and on the off chance you get to travel and observe the next eclipse, these are great tools for doing that, even if you give up on the sky altogether and, at least get them for that.
With a filter.
Without a filter, when it's total, with a filter.
Every time, all the rest of the time.
Yeah.
Eclipses are about a couple hours long. Okay.
Yeah. Dale.
One other comment on something that went by a few minutes ago. If you're out there trying to look through a telescope, not using a camera, using your eye to look through a telescope, but it's nice to use your cell phone, say, what is that thing, and you're looking, where is it?
Right.
Well, that messes up your night vision.
We should
And
talk
then you
about
look
that.
at the eyepiece, and you say, why can't I see it? Or why does it look so dim? It's because you wiped out your night vision by looking at a bright cell phone screen.
Or you can turn the cell phone way
So
down.
if you can turn
We're about to demonstrate that. I know they do it on Android, but you're used to your cell phone and you hate the dark. You got, one, get used to the dark, two, slide the cell phone down so it's dim. There's even more things you can do. There's a color filter setting. You tap this 3 times and you use red light. Why? Because red light is light that does not rob your night vision as fast. Your night vision recovers quicker. However, if you go full blast, you still have some night vision recover even with a red light, Laura.
Get a red filter on your flashlight.
Yes, I actually brought one. It's around there somewhere. But yeah, get a filter because safety is also important. So if you have a flashlight, and I will find mine. If you have a flashlight, let's see, yeah, red flashlight. You can still see objects in the dark. You're not killing your vision as much. Now, if it's bright enough, it will still, the grizzled veteran will still tell you to turn the light off, and it'll shoot a hose at you. But for your casual star parties, arm yourself with a red light. You have no idea what's going on, you're looking at it. This is far better than this. Where's the light on this thing? That bright light is ruining night vision left and right for other people that are out to observe. Now, if you're observing by yourself, use whatever light you want, but I still recommend you go with your red light.
Great.
Because you will still let your night vision develop. Most folks, somewhere between 15 and 30 minutes.
Right.
And you start to see, like, you might not see that door back there. We shut all the lights off. You barely see the hand in front of your face. You give it 5, maybe 10 minutes, and you gradually start seeing chairs. You get to where Mark and Doug are. You start to see gentlemen right there. Your eyesight will adjust. And part of learning telescopes is learning your night vision, embracing your night vision, embracing your fears that there's a prowling mountain lion on the loose that's going to kill you. No, they're not, at least not that I'm aware of. Learn where the species are in the places that you go. If you go out west, yes, there are mountain lions. Truth about animals, and that pertains to telescopes, because you're somewhere dark and you're enjoying the view of things you can't see back home. Most species do not want a part of human beings. So stand tall if they show up. If you see little eyes, stand tall and just stay calm. You demonstrate fear and you run, you might trigger an instinct to chase. You don't want that. If you observe with friends, you are now a group of human beings.
And you want one that's slower than you.
You want one that's slower than you. If you go to bear country, that may be your only defense. We don't know where everyone stands on the firearms, so we are not going to discuss that. That's a whole different series. Survival can be as simple as throwing something at it and it realizes you present a fight. Even if you don't, it just turns and goes away. Most of what I've encountered are deer snorting at me because I'm human, but they usually go the other way. I had 2 coyotes calling while at one of the parks up here, Port Crescent. They howl at each other. I listened as they got closer, and I said, oh, okay. And then I heard them get further and further away. And I go, no, they must have caught wind of me and said they didn't want me. So human beings, apex predators. Now, unless you scream and shiver or you cut yourself, I mean, there are ways you can see if animals will be attracted to you. I recommend you focus on your observing, stay aware, or do what most sane people do, and that's observe with friends. The more of them there are, the less interested. We were out in an open area with any animal that wanted to walk up, saw 0 animals. It was just me and Brian Autumn taking pictures, and I was observing with this little telescope, not an animal in sight. Just had to use the flashlight to watch out for the cow dung because there was some out there. But that's advanced observing 401 when you go out to where it's really dark. So it is 9:03. I don't know how much time do I have. I think more question and answer would probably be good. 'Cause I didn't even talk about this setup, but this is just a more advanced setup of this with a camera attached, an intervalometer, a connector to the intervalometer so I can have it take images while I fight mosquitoes, bugs, and defend myself against animals. Once that's done, then I look and see how crummy the images are, and I go out, throw them out, and go buy a Sea Star. So
one advantage members have is being a member of a club, is that we do have loaner telescopes. And,
yes.
And I always tell our members, if you're interested in getting a telescope, don't give them one. Try the different types of telescopes. You can borrow ours, take one for a while, try it out, bring it back, try a different one.
Yeah, one of the fallacies that affects telescope owners as well as your imagers is if you got big wads of cash, you can instantly get good at the hobby because you got the best gear. That camera is about 15, I don't know, it's almost 20 years old now. It is modified for Astro, and you're welcome to come up and see the image that I took with it. In fact, that one is an AT70ED. It's an Astrotech refractor. Yep. Yeah, and that I would like everyone to come up and take a closer look at these scopes once we're officially done with the talk. But yeah, there are so many telescopes you can try. There's one type of mount that I do not have up here. Bonus points if you can tell me what that type of mount is.
That's so neat.
Dobsonian, you're already a treasurer, so you already own the money for the prize. So Dobsonian mounts are great. They're the type of mounts that house the telescope Doug was talking about. Mark's and all of us have looked through that have done this. Big wide views, big beautiful views of the cosmos or the Dumbbell Nebula, which everyone seems to point at with their 30-inch mirror. We're looking at the Dumbbell Nebula. I saw it through this 2-inch. So the idea behind the big scope is to see if you can see some object or part of an object you haven't been able to see when you get into your deep observing. Like you may want to, you look at the dumbbell, well, you want to see, can I see the central star? Are you talking planetary nebula, the ring, the helix,
Galaxies, that's where the big telescopes.
Galaxies collect enough light for H2 regions of galaxies to be visible, especially in places that are dark. And those are the sort of things you interact with the scope. I've been guilty of seeing it, oh, I see it moving along. That's no better than just taking a picture of it. The idea, one little trick with observation is continue to look at that object. You're looking at it. Little details about it may start to pop out. You're actually gathering more photons from that object, and you may start to see more detail. M81, I think, is the cigar, right? That's a good one to look at. Or is that the M82 is the cigar? Yeah. Yeah, looking at, the longer you look at one of those galaxies, now M82 is the cigar, the more interesting one. M81 is the spiral, it's a grand spiral. The longer you look at it, the more features you may see as you're observing. So learning about these objects. Dale.
Why don't you explain using averted vision?
Averted vision, or some call it perverted vision, when you just can't see the darn thing at all. Averted vision.
We call it perverted imagination.
Perverted imagination. We'll get to, perverted imagination is in the biology section, but we'll talk about averted vision. Best way to talk averted vision is this. Say you're looking right at somebody and making them feel awkward and uncomfortable. That would be you. I still want to see you, but I'm going to look away and I'm looking at the great panel. I still see you, but I'm looking at the great panel directly. That's averted vision. You're looking at someone, but you can still make out the people that are there. When you do that with celestial objects in a telescope, the edges of your eyes, I think it's the edges of the cornea, may pick up details. All of a sudden, you may see things that you can't see directly. This is a diffuse galaxy. I don't see it. It's not really there. This thing's a liar. I'm going back into astrology. No, take some time, look away. You're in the eyepiece like this. We'll actually use the telescope too. You're in the eyepiece like this and you're looking directly in. Turn your eyes a little bit and look this way. All of a sudden, something bright may appear, something white may appear, and you do it a number of times and it keeps appearing in the same place. How people find comets. It's a fake comet, but they know their go-to works, they've tested it, they're on the object, they continue to look a little to the side, and this fuzzy thing keeps popping up. And they go, oh, I don't see it anymore. I see it. And it keeps showing up in the same place. You're using averted vision and you're observing something faint, fuzzy. Maybe it's coming in, it's so many light years or maybe even so many light hours away if it's a comet coming in. Right. It's small and faint, but you're able to observe it with averted vision. It works a lot better than, so we see by light, and the different areas of our eyes pick up different parts of light, and it picks up, some of it picks up detail, others looking at it directly, if it's bright enough, you see the object directly, and you know, that's also for the biology thing, but it works for observation. And it's called averted vision.
You get used to it, you start.
Yep.
It helps you.
It's a technique that you use when you're not sure you're actually seeing something. You look away from it a little bit, and if it appears, there's this bright little dot over here or something that you're looking at. You're using averted vision to see that object. Next
You
question.
know, also when you're observing, you can, using techniques like that, you can increase your ability to see things.
Yes.
Sort of train yourself. There's a famous observer, I guess, many of you guys have the planetary map.
Yeah.
I think his name was DeCicco, I think it was.
It feels like DeCicco.
But
Yeah.
he was noted because on Saturn's rings, he observed through a 105, I think it's 105 millimeter teleview, and he could actually see radio spokes on the
Oh, he
rings.
saw the spokes
And all
on
the
the rings.
professional astronomers said, no, you can't see, that's no such thing.
Yes.
Finally,
Then Cassini went out
yeah,
there.
Cassini, and they actually photographed it. This
Yeah.
is a guy through a 100 millimeter refractor with his human eye, he can see something that's professional, with gigantic telescopes didn't pick up on.
Your eyes may vary, but the more you're used to seeing these objects, and pictures can validate what you see. I have a similar story, maybe not as grand, but Milky Way photography. I love doing that, right? As of late, I've come back from places where the Milky Way just is in the sky. You're just looking at it like, look at that, looks like a picture. That's exactly how I see color, structure, lines, all of that going on. I go back to Lake Hudson. So Lake Hudson's a place, it's dark, but compared to places out west, you feel like there's too much light. Turn off the light. No, you can't. It's all around you. But I look up and I start to see the same dust lanes hanging there, structure, even a hint of color. And I've seen that band go by Orion at Lake Hudson. The more you get used to seeing celestial objects, whether it's in your telescopes or even naked eye, because you spend way too much time out at night, the more you recognize them at other places. Even if it's a little brighter, you're still seeing it. It's like, oh, it's right there. Maybe some of it's your brain, others it's you build your acuity, I guess is the word, for being able to see stellar objects. The more you do it and the more you observe. And so that, for me, it's Milky Way. It's seeing the Milky Way clearly in the Upper Peninsula and then seeing it even more clearly, and then going back to Nebraska with a moon maybe half as bright as that light over there and still seeing the full structure and color of the Milky Way. Took a picture and sure enough, it turned out to be a pretty bright image. So.
And the one thing you didn't mention, the sad state of affairs is that as you get older, your vision gets less sensitive. Things that you can see when you're 20, 25 years old. I see that all the time when I do a star party or something like that with kids at it. And I have kids look through my telescope, and I said, you know, you might see such and such. They said, oh, I can see it, no problem. I said, you saw that?
Yeah, I was just kidding.
No, kid you.
Go get a sea star. Done.
It's another reason to do astrophotography.
Yeah, there's.
I'm trying to get cataracts.
Yeah, and so the good news about astrophotography and getting a sea star is if you have a genuine interest in seeing these objects, but your eyesight is crap. If I threw that bottle at you and it would hit you before you would know it was there. The brightness and the level of brightness that can show up on, and I recommend a tablet, with your automated telescope. C-Star is one of them. There's an EV scope, and then there's a different scope. Explore Scientific has their version of it. It looks kind of like this, but it's automatic. And it'll run through the sky. You control it the same way as you do a C-Star. And the image of what you're looking at is on your tablet.
Or you have an observatory.
Or you have an observatory. You can spend, I don't know, how much.
Zero time out there.
Yeah.
You program it up and it images all night long, and you look at your images in the morning.
Yeah, and if you want to know about observatories, talk to Doug Bach. I think he's given a talk. He's got an observatory. And even he likes using a C-star. Why? Tell him why.
It's portable.
It's portable. Not all the skies are dark. The observatory sits in a reasonably dark area, but there's light pollution nearby.
So I can take my C-star up to my other property in Boone, where it's pretty dark, and set it up in 5 minutes.
So if you're interested in seeing, yeah, go ahead.
And I have it automatically doing imaging while I pull the 18-inch dot out into the visual.
There you go. Combine the two. Camera on this scope, taking images, or your automatic camera if you're not interested in the ins and outs of how the equatorial mounts work, how the right ascension follows the night. So you see where this is, follows the night sky. The object stays in that field of view in the same angle as it rolls through the night sky. Right ascension. Declination is the other one that I'm trying to turn here. Turns the scope this and that away. Declination. And together, these objects track the sky. C-star takes care of that for you automatically. This equatorial mount is equivalent to a thing called a wedge that you can get for it, so that your C-star follows the night sky just like this and takes advantage of the smoothness of an equatorial mount in that follows the Earth's rotation. The object in the sky is going to rise here. We've been tracking, and if you have vision, you may notice that that's moved a little bit since, because it's following that object through the sky. And that's what the equatorial mount is good at. You can follow the object through the sky with this. So, manual, or you let your electronics do it. Yeah, you're moving with the Earth's rotation with equatorial mounts. So, more questions?
Magnification, we know that magnification is focal length divided by the focal length of the eyepiece.
Yes.
And you take the eyepiece out and you put a camera in there. The camera doesn't have a focal length. How do you figure out the magnification?
So, you figure out point of focus. Your magnification, you would have to estimate what shows up on the back of your screen to the picture. What eyepiece would give you that same size picture of that object?
Different situation.
Yeah, it's all different situation. It's like this, I get a moon that's more magnified than if I have a 150 to 600 millimeter lens. So I know that the magnification is more than what I get with 600 millimeter.
Take your focal length of your telescope and divide by 50 millimeters.
Oh, that's it? Yeah. Okay. Because that's a 50 millimeter.
Or is it 35 because of the size of the sensor?
No,
50.
50.
Okay, yeah.
So 2,000 divided by 50, that's your magnification.
Yeah, this is a focal length of 1,250. If I divide by 50, that's the magnification I'm seeing on my camera.
The only caveat is, it will look different depending on the size of the image sensor.
Okay, because I have a full frame sensor in that one.
Well, even so, that's still a 35 millimeter. If you had a bigger sensor, it would look, this object would still be the same size.
It would be smaller.
But it would look smaller because of your rendering on the screen.
True.
And
So-
actually going back to your cell phone, that particular program, the SkySpark, comes with a built into it. So you plug in the focal length of your telescope, the particular camera has, and it will tell you exactly, what the field of view is gonna be on the screen. It's
I'm
gonna
glad
show
you
you.
said. You
Yeah,
see
it's gonna
that,
show
you see that
exactly
rectangle?
How much you'll cover.
That's an 85 millimeter view of the sky.
Yeah.
As I'm planning, what can I get with an 80? If I replace this with an 85 millimeter lens that's over there, that's how much sky I'm gonna get. And that's how much sky I imaged. Of course, I didn't download it to here. I just took a swath of area
in the Milky Way where some large dark nebula were. That's Astronomy 301, large dark nebula, whatever that is, and other objects. And I had them in an image. And I planned it all out with this. So that's Astronomy 201, because planning is a huge part of having a good experience out there in the night sky. What am I going to look at? Even if you go out there, everything is too small and it's hard to see, at least you're learning. You learn your telescope, you keep at it, you get folks to come look at it, help. I can't reach focus, everything looks like a blob. Well, let's try this little bitty trick. Who's ever done this before? Pull the eyepiece out a little bit. Oh, it's in focus now. Those little tricks are things that help you figure, okay, where is the focal point? I had to do that with this camera hooked to that scope. I had to rack it all the way out and start pulling the camera itself out a little bit till it got into focus. I observe with that. I don't do much imaging with it because it's a nice little portable companion. If you don't get a C star and you really want to observe, you know, a little scope, the larger, if you get to a 6-inch scope or even an 8-inch, enough of a light bucket to pull in with bright objects. So this is officially, the talk ended about 15 minutes ago, you just didn't know it. But we're still doing question and answer, and I would invite everybody to come up and look at these beautiful scopes and ask even more questions till we get kicked out of here, because it's 9:21. So with that, Bob.
All right, I'm going to close it up and let the viewing audience here see our scopes. All right, well, you guys don't get to come up and see the telescopes.
Nope.
Oh, well. So our next meeting is next Thursday, next week, July 17th at Macomb Community College, South Campus, 12 Mile and Hayes. Our next star party and open house is Saturday, July 26th at Stargate Observatory. And we meet afterwards at the Redcoat Tavern, Woodward, north of 13 Mile. And with that, the meeting is over. Good night, clear skies, and safe travels, everyone. Good night.
These scopes is balance, and you set them up.
Right.
Do this.
I'll let you shut that.
Oh, no, I'm not gonna say anything else. I just want to see how you have things hooked up because.
Oh, this is a total cool kludge here.
Oh, I know. So I work in AV and when I deal with it all the time, I get, and this is just me, I get frustrated when things don't work.